Anyone have any question? Okay, just ask. Okay, don't like.
Yeah. Sorry, Eugene. Quick question. Can that same rule be applied to shear flow, or only for this case of unsymmetric loading?
You can now shear flow. You have to be careful. Okay, shear flow has no twisting. Right, Oliver? Am I right? Shear flow, you're not counteracting any twisting. Am I right? Where are you now, Oliver? You gone quiet. You're
True. Yeah. But in shear
yes.
flow, usually those on the flanges, that direction, as you mentioned earlier, is fairly arbitrary. But in this case, could be used as a rule to guide us, or no?
Yeah, it's to counteract the twist, yes or no? Relative to the centroid. Am I right? Okay. So we have to be really, 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 really careful. Yes. Okay. Hey, you guys, you know what? The question that you asked is really, really useful in understanding the topic better, and I appreciate that a lot. And I've not thought about it, okay, until you guys start start asking, okay. Will the marking Excel be forgiving enough to allow us to neglect stuff like this? Cole, what do you mean?
I was just talking about like when you were neglecting the half thickness of the beam above. Excel you use to mark our tests will say that we're wrong if we do neglect it.
Yeah, Cole, first of all, you have to know this, okay? I am the gorilla creating the marking scheme. I am the gorilla that is that is creating the Excel spreadsheet. I will not trust the TA to do it. You get what I mean, Cole?
Yeah.
So if I say you neglect T, okay, you neglect T because the gorilla down here will also be neglecting the T. Are we clear?
Right, gospel.
Don't worry, okay? Okay, don't worry, okay? By the way, those spreadsheets that you guys see are all created by me. That's why online testing, okay, to test you guys, it takes me 3 times more time to prepare a quiz than when I give you face-to-face, okay? Because I do care. I want to know who are the A's, who are the B's, and who are the C's, okay? Other prof might not give a shit, but I do, unfortunately. Oh, shoot, we're recorded again. Bloody hell. Okay. It's okay. Right. So the next thing we're going to do, the next step we're going to do is we're going to take moment. Okay, we're going to take moment. We're going to take moment. About C now. Okay. So we know we have this, and this value over here is I'm going to call this my FBD. And our FBD we found earlier is equal to FBD. Wait, we know that it's equal to 288 over 233 BT. Okay, 288. Okay, FBD. over 233, right? And VT. Likewise, FEF over here is equal to 288 over 233 VT. Okay. So we are going to take a moment at point C. Okay. So we are going to do now what we are doing now is we're going to do static analysis. I repeat now, we are going to do static analysis. Okay. So we are going to carry out with static analysis. Okay, we're going to carry out static analysis. So this will be summation about moment. Okay, so if we were to draw our transformation, okay, no, don't need to draw a transformation. So we're going to take moment in the x direction, right? We're going to take our moment. So if we were to draw our transformation, this is y, this is z, and this is moment, right hand rule, rotation about x direction. Okay. So this will be equal, and we're going to take the moment at point C. So I'm going to label this point as point C is equal to 0. Okay. So we have FBD. So FBD and FEF are all going to generate anti-clockwise direction, right? So positive twice FBD. Oh, okay. Let me don't confuse you. So FBD multiplied by a distance of 3 plus by FEF multiplied by a distance of 3. Okay. And then over here we have V, right? V is equal to the distance is, so this is B multiplied by E, right? So the whole thing will be equal to 0. Okay. So now, so FBD will be equal to 288 over 233 VT multiplied by 3, right? So the same thing, 288 over 233 multiplied VT multiplied by 3 plus by VE is equal to 0. So our objective over here is to find E. Okay. So E will be equal to twice. Okay, will be equal to minus twice, right? 288 over 233, right? And then we have V multiplied by 3 T multiplied by 3. Oh no. Why do I multiply by, okay, so wait. Multiply by 3. Yep. Because it's the perpendicular distance, right? So then, because there's a V on the left-hand side, I bring it down so we can get rid of the shear force, okay? So this will be equal to 2 times 3 times by 288 divided by 233. So this will be equal to 1728 over 233. And then multiply by T. So this is 1728. Sorry, this will be have a minus sign. Divided by 233. Multiply by 3 is equal to 1 over 8. So the shear center is at 0.927. Okay. So 0.927 minus inches. Okay, so I'll do it again. 1728 over 233 times by 1 over 8 is equal to 1728 divided by 233 times by 1 over 8. So 0.927 inches. Okay. So the minus sign dictate that it's going towards the what? Left hand side. Okay, the minus sign. So minus. So the sign wise, negative means going towards the left. Positive means going towards the right. Okay, so it's true that relative to point C is going towards the left. Okay, so that is our answer. Right. What do you think? Is this easier than what we learned before? Anyone? Yes? No? Maybe? No comment?
I think so. But also when you did the solution procedure, like that was really helpful. Like, can you do that for like every problem from now on?
Yeah, because you guys were, I mean, I also need it, okay? Right.
Thank you.
So from here on, we are going to find the shearing stress distribution, okay? We're going to find the shearing stress distribution. Now the integration is really easy, okay? It's Mickey Mouse stuff, okay? Don't stress over it, okay? And I need you all to pay attention regarding the shear stress direction. So next we're going to find the shear stress distribution. Okay, so let me copy the image again. Okay, so there are a few points that, so to find the shear stress, again, the formula will be shear is equal to VQ over IT. Really, really straightforward, easy formulas. Okay, you can't go wrong. Okay, so now we how many points are there? Okay, how many points are there we're going to find? Okay, so watch this. Okay, so we're going to find the shearing stress at point A, right? Shearing stress at point B, shearing stress at point D, shearing stress at point C. Okay, so I'm going to call this my point C. Okay, shearing stress C, D, E, F, and G. And some of you will say, G, we'll be here the whole day. Right? We'll be here no, we'll not be here the whole day. So based on observation, okay, if you look at observation, at A, at D, at E, F, and at G, what do you realize? Can anyone tell me?
It's zero.
Symmetrical.
Yeah, it's equal to 0, and it's symmetrical. You're right. You're absolutely right. Okay, it's equal to 0. Okay, so what we can write down here is that shearing stress at point A, shearing stress at point D, shearing stress at point F, and shearing stress at point G, they are all equal to 0. And can someone tell me why they are all equal to 0, please?
It's at a terminal.
It's at the terminal, and at the terminal, what will happen is Q is equal to what?
0.
Okay, Q is equal to 0. Now, that leaves us with point B and point F. That leaves us with point B and point E, sorry. And also leave us with point C. Okay. So now, we know, okay, right? What we know is this. At point E, right? At point B. Okay, at point B, there are 3 shear stresses. Okay, I want you to take note. This is important. Okay, at point B, there are 3 shear stresses. Okay.
Can I just clarify something, Eugene?
Yes.
Did you just say that the Q is 0 at the terminals?
Yeah, because
is there a terminal at near B, like between A and D, or where are the actual terminals then? Because we've been putting them in places where it's kind of been confusing, in the middle of junctions. Okay, so those are the terminals?
Yes.
Okay, that makes sense.
C is the centroid mark.
I just was confused. I thought maybe you put a dot there for some other reason, but
C is the centroid. Okay. So,
okay, cool.
Could I also ask a question about the terminals?
Yes.
For the Q, was it taken from like wherever the starting terminal is, or is it wherever the terminal that is closest?
Roseanne, can you repeat your question again?
Oh yeah, sorry. I was wondering if the Q could be like, do we take it from the closest terminal or from the terminal that starts the shear flow? I don't know.
Remember, over here, we're not dealing with shear flow. We are dealing with forces now, right?
Oh, okay.
Okay. So I'm not saying that there are some similarities. Okay. There are also some differences because the shear force, okay, and the shear flow happen to be very similar. Okay, so if you were to ask me to design Q, it will be the same as the shear force. Regarding